Right. So here, keep that point in your mind that what refraction of light is expected from a lens from its second surface because thickness of the lens is negligible. So refraction is expected only from right end. So here, from the right end, the light is going to refract. So where we can draw the normal here for the left surface, sorry, from the left center or from the right center. See the diagram. You can draw the diagram from left surface or from the right surface center. From the right surface center because you are expecting the refraction from the right surface. So I can join the point of incidence with the center. So this is called normal for us. Where the light ray actually above the normal or below the normal. See here. Above the normal. Is it clear? Are you following? That light ray is what? Above the normal. Then after refraction, it goes opposite direction to the normal. So below the normal. Then it is in the medium called denser medium. So we are not expected any refraction in this region. Only the refraction is expected in this region. So it is denser medium. Then entering into the rarer medium called air. So in what direction that light ray bends? In what direction that light ray bends? Towards or away from the normal? It is away from the normal, denser to the rarer. So here that angle between the incident light ray and refracted light ray increases. So here that light ray will select the path like this. Is it clear, everyone? Is it clear, everyone? Is it clear, everyone? Sir, నేను క్లాస్లో ఉన్నా 8:15 కి మాట్లాడాను. Is it clear? Any confusion? If nothing, I'll go for another normal here for the very bottom ray. Here it is the normal. So it is below the principal axis, below the normal. That light ray is below the normal. So here I am drawing the ray after refraction. It goes upward or downward after refraction. Anyone? Kaushik. It goes upward or downward. See the normal here. So incident light ray below the normal, after refraction, it moves away from the normal. So what you will get here after refraction? Converging point or diverging point? What you can expect? Is it converging point or diverging point given by the refracted light rays?
Converging point.
So converging point. Here you will get that point. That is converging point. Where it is located? On the principal axis or not? That converging point located on the principal axis because you are taken that light rays parallel to the principal axis. Any confusion? Nothing I am remembering. Just I am following the logics. No need to keep anything in your memory, right? Just I am depending on the one logic in total refraction that is bending towards the normal or away from the normal. But here negligible thickness is there. That's why we are expected that refraction only from the second surface, then remaining that light rays incident treated from denser to the rarer. Clear everyone? Go to quick reaction. Some more in confusion, I think. Tejaswini, Rohit. Yes, clear. So we'll go for another. So what happens after refraction from that lens? That light rays meet at a common point or not? These light rays, do they meet each other? If they meet, where they can meet? Here, they are all going to meet each other at a common point. So this common point you obtained here. Look at that. You obtained here. So simply, this point is called as converging point. That converging point is given by the convex lens. So when you instant a parallel beam of light rays that which is parallel to the principal axis, you are getting a converging point located on the principal axis, right? So that point now I am naming as it's a focus. It's a focus. Clear? What is focus? How do you define focus? How do you define focus? It is a converging point or diverging point in case of this lens. It is a converging point because the lens is given this behavior to the light rays. So that's why this lens is called a converging lens. So here, converging point of light rays after refracting from the lens is called as focus, right? So here simply I am going another side. If I reverse the direction of incident light rays from the second surface, right side, I'll get the converging point left side. So that point I am giving you eyes up to here. So how many focal points are there? How many focal points are there here? 2 focal points or 2 focuses, right? So here 2 focal points, 2 center of curvatures, 2 radius of curvatures for any lens. 2 radius of curvatures, 2 center of curvatures, 2 focal points. Okay, so simply if a parallel beam of light rays incident on a double convex lens, they can converge at a point after refraction. That converging point we can call it as focus. If you measure the distance between the polar optic center to the focus, what the length is measured by you? The length between the pole to the focus is called as focal length. Is called as focal length, denoted by the letter small f. So the definition of focal length is the distance between the optic center to the focus. Are you clear? Or any confusion? Go to quick reaction. So terminology of the lenses completed in this topic. Kaushik, Tejaswini. Right. So here now we are going to another diagram. So in this chapter, always I am not drawing the convex lens. Simply I am using the symbol of the convex lens. Right. So here I can give you that symbol of the convex lens. Right. So here look at on the screen. So here this lens is what? What the lens is drawn by me? Name it fast immediately.
Biconvex.
Biconvex. So here I'm taking one vertical line from top edge to bottom edge. Right? Top edge to the bottom edge, I am drawing one vertical line. So how I am observing that curvatures at the edges, I am giving you here logically. See here how I can expect that curvature from the edge. Is it clear? Is it clear? Just if you draw a boundary from top edge to bottom edge, what the lens you will get? Surfaces. Convex, convex. So both are convex. We can call it as biconvex. Is it clear? Is it clear? Or any confusion? So simply, this help me to remember the symbol. See here, what I followed the steps. First, I drawn a vertical line and how I observed that curvatures either sides from the edge of the lens, like this, bottom, like this. So this is only I can use as symbol for the convex lens. Is it clear? Did I remember? This is the shape. This is the symbol of convex lens. No need to remember. Biologically, everything you will get. Right? So I got the symbol of the convex lens. So using that convex lens symbol, I will show you the previous diagram. Right? So what happens if a parallel beam of light ray incident on a double convex lens? That is symbol is this one. Is it clear? Why I'm using this is only symbol for the convex lens? Because outline, if you connect these directions, top and bottom, you will get the shape, outline of the lens. That is why I'm using this symbol only for convex lens. Right? So then identifies centers, parameters. Right? So here, this is symbol of a convex lens. Here, I can identify its centers and respectively C1, C2 given. Then joining them called principal axis or optic center. Then identifying the pole, that principal axis and lens where they are going to be connected or coincides. That point is pole or optic center denoted by the letter P. Then here, just incident the parallel beam of light ray parallel to the principal axis. After refraction, they are going to converge or they can meet on the principal axis opposite side to the lens. Incident light rays left side, then refracted light rays are going to meet each other right side. So that point here I called eyes focal point or focus. Right? So here that converging point here left side also available if you incident the light rays from the right surface. Okay, so that I am naming as F2. So here this F1 and F2 are called as focal points. After refraction, that light rays are going to be converged. That converging point only named as here focus or focal point. Okay, so here the distance you measure between the pole and focus is called as focal length, denoted by the letter F. The definition is simple. Distance between pole to the focal point. Any confusion? Are you clear? No reaction. Kaushik, okay. Who is Surajita? Yes. Abhinay, Rohit, you are given your response. Are you given? Or any confusion? Yes. So no confusion? Right. So next, did you got what is focal length? Our topic is focal length of the lens only. So I got what is focal length of the lens, especially convex lens, the distance between the pole and focus, or the distance between pole to the converging point. Right? So this is focal length. Then I'm taking now double concave lens. What happens if parallel beam of light rays incident on a concave lens? Right? So I have to draw concave lens now with two curved surfaces, curved inward, especially concave surfaces. Then I can connect the curvatures, top and bottom edges. or ends, then I got a symbol, diagram of a lens. Then identifying its centers. So no need to say why I am taken center of curvature left side first one. Can I say, or can you say? You can say now. Anyone? Why I taken this C1 left side? But in the previous diagram, I used C1 right side. Why I took that left side? So this is first surface for me. If I imagine this eyes like this, where it's center, left side or right side? Is it left side or right side? Medashri.
Left side, sir.
That's why I'm naming it is a center 1, C1, first surface center, C1. Is it clear? So where you get second surface center? Towards right side. So simply I'll get C2 right side. Right? So C2 I got. Then the line which is joining the centers called principal axis. Identify the midpoint in its thickness of the lens, that we can name it as pole. Right? Up to here is very clear, or any confusion? Same terminology related to the concave lens. Clear? Right. So now, parallel beam of light ray, that which is parallel to the principal axis, incident on a concave surface. Right? Where you can expect the refraction. On the first surface or on the second surface? Reply me. First surface or second surface? Refraction is expected from. Give me your reaction. Reply me.
Second surface.
Second surface. So from which surface I have to draw the normal? From the second surface or from the first surface? So second surface only, because you are expecting the refraction from the second surface. So I have to draw the normal to the point of incidence from the second center. Then here you can see the angle of incidence above the normal, below the normal. Here is the angle made by the incident light ray. So where you can expect the refracted angle, above or below the normal? Above or below the normal? Answer me.
Above.
Opposite side, that is above here. So here you can expect that. Okay. So here simply you are going to expect that angle of refraction more than the angle of incidence, because tens are to rarer. Here you can imagine that light rays are coming from the lens only. Right? So refraction expected only at second surface. So using the same logic here. Okay. So then what happens? That light ray bends in which direction? Away from the normal or towards the normal? Away from the normal. So like this, that refracted light ray behaves after refraction. So let us see here. What happens if that parallel beam of light ray incident on the concave surface? So here, the ray which is along the principal axis remained undeviate. Okay, then see here how they are after refraction. They are going to meet each other. Answer me. Reply me. Do they meet after refraction? They never meet for any extension, because the distance between them is increasing. Gap between them increasing. See here, I'm showing you normals. I'm showing you normals. Clear? Is it clear? Yes. So here now we are getting the converging point here after refraction. Do we get? No. So we will go backward in direction. So Here, refracted ray extended in backward direction using this dotted line. See, each and every refracted light ray extended with the dotted line in opposite side, towards opposite side. So here, you will get a common point given by them. Is it? Do you see that point? Do you see that point? Where you got that point? On the principal axis, right? So that point is what here? Diverging point. All the light rays are appear to diverge from a point. So this is the reason to say that concave lens is a diverging ray. Sorry, diverging lens. Are you clear with this point? Because after refraction, that all the light rays are appear to separate from a common point. So that common point is called as diverging point. So this is the reason why I am calling this concave lens as diverging lens. So this point, diverging point, is called as focus. So focus is nothing. It may be the diverging point or converging point respect to the lens. So this diverging point also available towards right side. So that I am giving as F2. So F1, F2 are what? Focal points given by diverging of light rays. Okay. So here, simply, if a parallel beam of light rays incident on a double convex lens, they seem to emanate from a point on the principal axis after refraction. That common point is called as diverging point. That diverging point only called as focus. Then you are able to measure the distance between the pole and focus. That is called as focal length and denoted by small f. Is it clear, everyone? Go for quick reaction. So I got what is focal length of the lens. To the concave lens and for the convex lens. So no confusion, I think. Then in the ray diagrams, I can use the symbol for the concave lens, right? So for this, I am giving you the symbol made of two curved surfaces here. Made of two curved surfaces. So here I will show you that curved surface by drawing here. Just a second. I'll take the shape outline. So here I have a sphere. I need to cut this into, sorry, change the color. So one of the surface is cut like this. Then second surface I am cutting. What do you see on the screen? What do you see on the screen? Anybody? What the lens type I have on the screen?
Biconcave lens.
It is biconcave lens. Both sides I have concave surfaces. Now I'm drawing one vertical symbol. Right, line is taken. Then how I am feeling that surface is curved inward, right? Curved inward like this. Yes, like this. At the bottom edge also like this, right? So what the symbol I can use for convex lens? So line, right? At the edge, I am showing that symbol of a curvature. So it is looking like this. So this is the symbol I am using for the double concave lens. Are you clear how I am remembering that a symbol of concave lens? Are you clear or any confusion? Right. So this is the symbol I am using for the double concave lens. So centers identifying C1 and C2. Then the line joining that centers called principal axis. Then what happens if you incident parallel beam of light ray on the double concave lens? After refraction, they appear to diverge from a common point. So that reverse direction, if you are extending that light rays, you will get a common point given by them. That common point is called the diverging point here. That is also located on the principal axis. Why it is located on the principal axis? Why not above or below? Because here you are taken light rays parallel to the principal axis. If you take that parallel rays other than or non-parallel to the principal axis, parallel beam of light rays not parallel to the principal axis. So that we have special condition. I'll show you that later. So this point is called focus. Right side also you have focus F2. Then simply these points are called here focal points, diverging points only. Then the distance you are measuring between pole to the focus is called focal length. So this is symbol of a double concave, convex written here. It is concave lens. This is concave lens. So are you clear about this one? Any confusion? Go to quick reaction. Is it very clear? Clear? No doubts to ask anything? Right. So here I got it. Terminology related to concave lens and convex lens. What the terminologies are? Here center of curvatures, radius of curvatures, focal points, right? All these are 1 and 2 available, right? One pole, principal axis, right? Next, the focal length. Only one focal length is available, right? Only one focal length is available. So these are the terminologies. Remember that, right? They are all definite quantities. We are able to define them, right? Definable quantities they are, right? So next topic for us is simply here. What happens if you incident light rays on the convex lens, right? So here on the convex lens, what happens if a parallel beam of light rays incident on a convex lens, right? So here, not only this parallel beam of light ray, other than parallel beam of light ray, we can take, right? So here simply, if a light ray is incident on a convex lens, that is simply here passing through the center of pole. First condition, I'll take ray passing along the principal axis, right? Sorry, pole I said, principal axis, along the principal axis for any lens, So here, simply, I drawn convex lens, identified its pole, identify its center of curvatures also, respectively C1 and C2, then connect them. This is called the principal axis for the convex lens. So here, next, here identify its focal points, respectively F1 and F2. Remember that gap you must maintain equally between any 2 points, pole to the focus. That means P2 F1 or P2 F2, same distance. P2 C1, P2 C2, any distance same. Okay. So it will help you to draw the ray diagrams easily. Now I taken a light ray along the principal axis. Look at here. A blue color light ray is passing along the principal axis onto the lens. What happens after refraction from the lens to this ray? Can anybody guess how I incident? So here it is along the normal, because the line joining the pole and center is nothing but normal. So it is along the normal. remains undeviate after refraction. This is situation 1. In case of concave lens, so you can draw the same pole, center of curvatures identification, then connecting them called as principal axis. After that, identifying the focal points, right? So here, instant a light ray along the principal axis on the double concave lens. After refraction, it is also remains undeviate. So this is generalization. They are remains undeviate. These are given in figure number 9A and 9B. So ray passing along the principal axis of any lens remains undeviate. So this is the generalization. Are you clear? So no verification diagrams here. Logically, you need to remember that. Along the principal axis remains undeviate. Along the principal axis remains undeviate. So we'll go for second situation. That second situation is behavior of light rays only. Second situation is simply here, that is passing through the optic center of any lens. Optic center is what? Pole, P. So here identifying the pole and identifying its centers, connecting them called as principal axis, identifying the center of, focal points, naming them as respectively F1 and F2. Then the ray is instant on a double convex lens through the optic center of lens. In this case also, that ray after refraction remains undeviate, right? So remains undeviate. In case of concave lens, also you will notice that same thing, that the light ray remains undeviate when it is passing through the optic center of the lens. So the generalization is simply it remains undeviate after refraction, passing through optic center. So two rays, which remains undeviate. What they are? One is along the principal axis and the other ray is passing through the optic center. They remains undeviate. Then we'll go for the situation 3. That situation 3 is simply here the ray traveling parallel to the principal axis. Already we completed while we are deciding the focal point or focal length. What is its behavior in case of convex lens? A ray passing through the lens along, that which is parallel to the principal axis, that remains undeviate or it deviates from its path. If it deviates, what is the direction? What is generalization? Rays are parallel to the principal axis, above or below. See here, red color line is taken along the principal axis. Along the principal axis remains undeviate. Then what about the remaining rays parallel to the principal axis? Can anybody? They can meet each other after refraction at a common point called focus. So here they are going to be converge. They are going to be converge. In case of concave lens, so here they appear to diverge. So here focal points identified. See here, if a ray incident parallel to principal axis at any gap, right, they are diverges. So here along the principal axis remains undeviate. Remaining rays are going to be diverge. So here in the backward ray, you will find out a common point located on the principal axis called as focus. So here, this is your observation. Is it clear? So here, parallel to the principal axis, they may converge at focus or appear to diverge from the focus. This is the generalization I gave you. Depending on the lens, you can select, is it converging or diverging? Is it clear? Is it clear? Then we'll go for next situation here. Situation number 4, that is here simply ray passing through the focus. Ray passing through the focus. What happens? So here simply what happens if light rays are passing through the focus of the lens and incident on a double convex lens. So pole is identified and its focal points are identified. Then rays are focused on the lens, which are diverging light rays here. See here. After refraction, they becomes parallel to the principal axis. This is generalization. It is the situation 3 conversion actually. Situation 3 conversion, right? So they becomes parallel after refraction if a light ray passing through the focus of a double convex lens. Here, if it is double concave lens, here they are also becomes parallel. But here they cannot pass through the focus. They appear to meet the focus before instead. So that light rays are like this. If you extend them, they appear to meet its focus, but they cannot meet. After refraction, they becomes parallel to the principal axis. So here, what you are generalizing, ray passing through the focus will take a path parallel to the principal axis after refraction. But here, ray passing through the focus is possible only in case of convex lens. In case of concave lens, it appears to meet focus, right? So this is observation in the situation 4. Then one special situation is there. That is here, special situation is a parallel beam of light ray, but non-parallel to the principal axis, making something angle with the principal axis. What this is, sir? Simply you can see by drawing the diagram here. Look at here. What is the condition applied? Parallel beam of light ray, but not parallel to the principal axis. It is making something angle with the principal axis. Look at here. Is it making angle with the principal axis or not? See here, where that angle you can estimate. You can measure that angle here. See here, it is making angle. What angle? Equal angle, because parallel light rays on the same horizontal line. So transversal concept you can use. If you extend these, they can make angle same, right, with the principal axis, right? So here I'm not measuring that angle, right? So what happens to these light rays after refraction? They are going to meet each other or not, right? So for this, I'm extending this blue color light ray without any deviation. Why? It is passing through the optic center, remains undeviate. Then what about the remaining light rays? So to get that remaining light rays behavior, I drawn vertical line passing through the focus to meet that undeviate light ray. So I will get a common point. That line is called here focal plane. The point you are getting is called imaginary focus. So this is imaginary focus. That light rays after refraction going to meet each other at that imaginary focus. Clear? So like this, you will get the behavior of light rays after refraction. If that parallel light rays, but not parallel to the principal axis, making angle with the principal axis. So in case of double concave lens, we can see that, or we can expect that here like this. See here. Parallel light rays, but making angle with the principal axis, right? Then after refraction, one of the ray remains undeviate, so extended. Where its focus located for the concave lens, left side or right side? Diverging point, left side or right side? Left side. So left side, I am drawing line, focal plane. Then it is identified. So here diverging point. Then you can extend in the same direction. They behaves like this. So this is special situation. Meeting time completed. So we'll continue our discussion tomorrow at same time 6:45 in our next meeting. Thank you.